Hey tech buddies, welcome back to Tech with Techtactical. Ever pondered how your computer figures out where to dispatch your emails or how you manage to binge watch your cherished shows? Well, it's all about IP and subnetting. Today we're catapulting into the tech cosmos to untangle the knots of Internet Protocol, or IP, and subnetting. In this digital realm, each gadget linked with the internet has a distinctive identifier, helping data to navigate accurately. So stick around, and by the end of this you'll morph into a bona fide tech whiz. Let's get this show on the road. Slide 1. What is an IP address? So, what's an IP address? It's your computer's unique identifier in the virtual world. Visualize it as a telephone number for your devices, mainly referring to the IPv4 type, the most prevalent one comprising of 4 groups of numbers. This unique address system facilitates the process of routing information, ensuring that the data sent from your device arrives at the correct endpoint. Slide 1 marked out. Before we move on to subnetting, let's dive a little deeper into the structure of an IP address. Understanding this structure will make subnetting much clearer. Slide 2, IPv4. Address example. Check this out. 192.168.1.1. The first part, 192, is like the neighborhood. 168 is the street, and 1.1 is the house number. Simple, right? Slide 3. Each part of the IP address is called an octet because it consists of 8 bits. The total length of an IPv4 address is therefore 32 bits. Slide 4. The IP address space is divided into 5 classes, A, B, C, D, and E. Each class uses the octets differently to specify the network and the host. Slide 5. For example, in a Class A address, the first octet is the network part, while the remaining octets are for the host part. This allows for a large number of hosts in a small number of networks. Slide 6. On the other hand, in a Class C address, the first 3 octets are the network part, and only the last octet is for the host. This allows for a large number of networks with fewer hosts. Slide 7. In the next scene, we'll see how subnetting can help manage this complex structure more effectively. Stay tuned. What is a subnet, you may ask? It's almost like creating neighborhoods in the expansive world of technology. It's a system that helps organize things in a better, more efficient way. Imagine having a very large city and you need to manage everything within it. Quite overwhelming, right? But if we divide that city into smaller, friendlier parts, or as we call it in tech terms, subnets, it becomes a lot more. Subnets are our way of making sure everyone has their own space and that the system runs smoothly. It's like administering a city in well-ordered smaller districts, ensuring the efficient routing of packets. Let's take a closer look at subnetting with a more relatable example. Think of subnetting as the division of a city into various districts. Each district has its unique characteristics, just like each subnet in an IP address. Just as a city is easier to manage and navigate when it's divided into districts, an IP address is more efficient when divided into subnets. This division helps break down a large group of IP addresses into smaller, more manageable units, akin to how districts function within a city. In simpler terms, imagine subnetting as sharing toys among a group of children. The more toys, or bits in the case of subnetting, you have to distribute, the more groups, or subnets, you can create. This way, every child or device gets their fair share, and it's easier to keep track of who has what. It's a way of bringing order and efficiency to a potentially chaotic situation. This analogy might be a bit simplified, but it gives you a good idea of how subnetting works. In the next section, we'll delve into the technicalities of subnetting, so hold on to your hats. So, how does subnetting come into play? It all boils down to the language of computers, binary numbers. Each IP address is a chain of 32 binary bits arranged into 4 octets. When we subnet, we partition these bits to establish the network address, the subnet, and the host. The initial segment, the network address, marks out the network itself. The second segment, the subnet, facilitates the segmentation of this network into smaller subnetworks. The third segment, the host, pinpoints the specific within these subnetworks. The magic of subnetting is that it diminishes network congestion and obscures the network's internal structure, boosting speed and efficiency. Let's bring subnetting to life with an example. Our IP address is 192.168.1.0. Fun fact, by allocating some bits, we can construct diverse neighborhoods like 192.168.1.0, 192.168.2.0, and so forth. Each is akin to its trendy hangout spot for devices. As we conclude, don't forget, technology is all about neighborhoods and addresses. If you enjoyed this video, smash that like button, subscribe, and ring that bell for more tech pleasure. Stay inquisitive, tech geek, and see you in the next one. Now let's weave these threads together. The Internet Protocol is the system that assigns unique identifiers to each device on the Internet. It's the backbone of the digital world, ensuring that data gets routed correctly. Subnetting, on the other hand, is the process of dividing a network into smaller, more manageable pieces. It's like splitting a city into different districts, each with its own unique identifier. This division allows for better data management, improved network performance, and increased security. In a world where digital connectivity is key, understanding IP and subnetting is like understanding the roadmap of the Internet. It's about appreciating the complex yet beautifully organized digital world that allows us to connect, communicate, and create. So the next time you send an email or stream a show, remember the intricate system that makes it all possible. The world of IP and subnetting, a world that's as vast and complex as it is fascinating.